Welcome to the Driving the World podcast series. I'm your host, Cully Holland. Today we have Julio Montoya, our engineering team lead, and we'll be discussing couplings. Hey, Julio, thank you so much for joining us today. How are you?
I'm doing good. Thank you for inviting me, Cully.
So, today we're talking about couplings in the heavy industrial gearing world. So, let's start off 10,000 foot view, very top. What is a coupling and why do we care?
Definitely. So couplings are mostly used for connecting of a rotating shaft in order to transmit the torque or the motion. It can also help a lot with compensation for misalignments between the two shafts, as well as dampening the system. We use them a lot, mostly for connection between the motor to our SEW reducer, or we can connect our SEW reducer to our application in that situation. And then there are some instances where we can also mount a reducer to a reducer, what we call an auxiliary drive at that point.
Okay, so we're transmitting torque, we're connecting different components. Definitely see how that could be very useful for a lot of our customers and a lot of applications. So between the motor and our gearbox, let's just go ahead and say we're going to refer to that as the high speed shaft side, the HSS, if any of our customers have seen any documentation. And then the output shaft of our gearbox to the application, that's going to be our low speed shaft side. So let's start. And what kind of couplings are we working with on the high speed shaft side?
Definitely. So we have a series of different styles of types of couplings that we use with our drive systems. Our most common used one will be what we refer to as the claw or a jaw coupling. Typically requires two halves and then a elastomer insert in the middle to help with that dampening and misalignment that I talked about earlier. We can also then move on to another type of coupling where we have the pin and bushing, pretty similarly designed to the claw coupling, but instead of using a claw style, we have pins with small elastomers around these pins and then connected to the secondary hub at that point to transmit that torque.
Awesome. And those are going to be our two main high-speed shaft side couplings. It's going to be the claw and then the pin.
Those will be the most common ones that we use. There's also been some pretty significant advancements in coupling technology. One of the ones that customers like because they're very maintenance-free is the tire coupling, where we have similar concept with the claw coupling, but instead of having a elastomer insert that goes inside the two hubs, the elastomer wraps around the coupling, so it's easier to basically replace that coupling without having to move any of the components around for like actual spacing at that point. And customers can pretty much super easy to maintain and remove and get it going again, basically.
Well, I know a lot of customers definitely enjoy easier service or easier maintenance, especially when it comes to the heavy industrial gearing side of things.
Definitely.
So we got the claw, we got the pin, we have a tire coupling on the high speed shaft side. Let's jump real quick to the low speed shaft side. I know there's probably a few couplings we've skipped, but we'll get to them. On the low speed shaft side, what are some common ones that we've seen? Does SEW offer any? What are we looking at on the low speed shaft?
Definitely. So with the low speed shaft, we come with more torque in that situation. So we're not going to have some more robust couplings. One of the most common ones that we use will be a gear coupling, where we have two hubs with gear teeths and then a spacer insert that basically helps transmit the torque from the application or the gear reducer to the application. And in that situation, one of the probably big disadvantages about the gear coupling is that unfortunately it does require a bit of maintenance because now you have that lubricant inside of it that you have to worry about.
Yeah, you definitely want a little bit of lubrication with gear meshing. Metal on metal is not always what we're looking for.
Correct.
So we have a gear coupling. What else are we looking at on the low speed shaft side?
Definitely. One of the most common uses, especially for mixer applications, is the flange coupling, where we have two coupling halves, which actually I have a nice example here for our viewers. We have a flange coupling design that I will cover a little bit more in the podcast, but this helps not only transmit that torque, but it also helps with transmission of the axial and the radial loads as well. As we know, mixer applications do generate a lot of that overhang load.
They do. They like pushing sideways, up or down, depending on the impellers. So I'm glad that the flange coupling definitely supports that. Is there another type of low speed shaft coupling that we want to talk about before we dive back into the flange and maybe some alternate couplings?
Definitely. So now we're talking more specific types of couplings for specific applications.
Sure.
One of them most commonly used for hoist applications is the drum coupling. With drum coupling, typically we use it for connecting our reducer shaft to the drum in a hoist. It helps a lot, especially with that handling of that overhang load that our gearbox will be interacting with because of the nature of the hoist in that application.
Very cool. So you and I were talking a little bit, and you mentioned that SEW has some flange coupling. So let's dive into those a little bit.
Definitely. So SEW, a lot of people doesn't not know this. And even it took me a while to learn that we actually do have the availability of our flange couplings. It is designed specifically to be used with an XE series units. It can also be used with other SEW heavy industrial gearing reducers. One of the big advantages that we have is that it is specifically designed to be used and handle very high radial and axial loads. And it works very, very well with our XE generation units. We also have different types of shaft hub connections. We can do either a key connection or we can do a shrink fit connection as well. It is very, very good to be used, especially when you're doing new installations or if you're completely changing both coupling hubs. Not so well with if the customer just wants to replace just one hub. Unfortunately, the bolt pattern typically doesn't match with the competitors out there.
That is one of the joys of crossovers, is trying to match, dimensions, bolt circles, bolt sizes, all of that. But that is cool. I learned that today, that SEW offers that flange coupling. So new installations or complete replacements, we definitely want our customers to think about that. And before we get into maybe some ideas of what goes into sizing or selecting a coupling, I just had a coupling pop to mind, and I've heard of them. I don't know too much about them. Fluid couplings. Do we do anything with fluid couplings? Kind of, where does that fit in? Which shaft do we use it on? Where do they live?
Definitely. So we do have access to the fluid couplings. A lot of applications, for example, conveyors, conveyor applications use a lot of fluid couplings where a smooth startup of the application is required. Obviously, you don't want the machine to turn on and then all the product that is in that conveyor to just fall over. So some customers could use a VFD, but the fluid coupling is a more low cost solution in that situation. And as the name suggests, fluid couplings, we're using fluid to transmit that energy from the motor to the reducer. They're mostly used as a high-speed shaft coupling. And then we have a plethora of options for safeties, make sure that the thermal couplings don't get thermally overloaded because of temperature. Obviously, you have fluid inside of it. The faster you spin of it, the more energy is going to generate, the hotter it's going to get. So that would be pretty bad if eventually we damage that coupling because of it.
Yeah. Thermals, thermals, thermals. That is something, once you get into heavy industrial gearing, you're always thinking about. And that's also know that a fluid coupling is an option we have on our high speed shaft side. When it comes to selecting these couplings, different types, they have different benefits, different things we want to think about. But in general, what should our customers or some engineers or even internal folks be thinking when they're trying to select a coupling? What do they need to know to make sure they get the correct coupling or the best coupling for their application?
Definitely. Definitely, number one, knowing what the application is, because knowing what the application is will tell you exactly what the coupling needs to do. One other thing that we need to worry about is any outside interference when it comes to forces, like, for example, mixer applications, or some situations where we have some varying temperatures as well in the environment. And the obvious, of course, knowing torque, speeds, and shaft diameters as well. There are some couplings that are limited to the size of the bores that they can actually house.
So pretty much the standard mechanical restrictions, always like those, got to have them. And then pretty much application, application, application. What are we trying to do is really going to help us go down the correct road for selecting a coupling. So I think this was a really nice 10,000 foot view of couplings. Is there anything we missed? Anything else you want to say, or do you think we about nailed it?
I will say especially for this is, like I said, a 10,000 view of what it is. There's a huge amount of details that we can go over. We could have a podcast that can be pretty long when it comes to couplings. So if you have any questions or concerns, or you want to maybe size up a coupling and you don't know where to start, definitely contact us over in the applications team or in the office. Even our field employees also are very knowledgeable when it comes to couplings. Always reach out to us, and we will be able to help you select the best solution for your needs.
Always nice to know that they have help and support, which I know you guys will get them right. Julio, I really appreciate your time. Thanks for coming. Hope you have a great day.
Thank you, Kali.